if I ask you to close your eyes for a few seconds and try to remember some of your summer holidays when you were, say, 9 or 10 years old, what would you see? The beach or the pool? Maybe some walks in the forest, barbecues, picnics, family gatherings? My memories of summer holidays are the wait for the sun to set. Gathering blankets, putting some deck chairs in my grandparents' garden, putting some mosquito repellent on my body, and taking a map of the night sky. I would sit outside for hours as little by little the stars would start to flicker in the darkness. I would sit there for hours while questions would be rushing into my brain. Why are there so many stars? Do those stars have planets orbiting around them? And if so, is there alien life? That, paired with the fact that I was a massive X-Files fan, triggered my interest in becoming an ufologist. If you do not know what kind of a job it is, well, first of all, it's not a job, as I learned later on. It is basically the search for unidentified flying objects or flying saucers that would have been sent to Earth by aliens. Let me tell you that my teachers were rather unimpressed by my life ambitions. So instead, I decided to become an astrophysicist. Fast forward to 2009, NASA sends a telescope in space called Kepler. Kepler's mission is to find other planets orbiting around other stars. We call them exoplanets, and it has truly changed our vision of our place in the universe. Since Kepler was launched, we have multiplied by 10 the number of exoplanets that we knew before the mission started. We now know around 3,000 exoplanets, confirmed exoplanets. And we also know now that having a planet orbiting a star is a very common feature. This is a representation of all multiple planet systems that we have found near our own solar system. And what you can see here is the diversity of those planetary systems. Some of them might have huge planets, and some of them might have very tiny ones. But what you can see here is actually a star have not just one planet, it might have 2 or 3, plenty. So with billions of stars in our galaxy, just figure out how many other worlds and how many diverse worlds there are out there. Amongst them, Proxima Centauri b. It is the nearest planet to Earth, orbiting around another star. And there are chances that it is a rocky planet, like our good old Earth. The icing on the cake is that it is also in the habitable zone, not too close and not too far from its host star, so that it can hold liquid water. And who says liquid water? Says possible life. So right now, I wish I could go back in time and tell my teachers that the search for alien life would become one of the coolest jobs in the 21st century. I also wish I could go back in time and tell my classmates that being a nerd and a geek would also become a cool thing in the 21st century, but that's just for me, I guess. So Proxima Centauri b, habitable zone, liquid water, possible alien life, end of the story? Not really, because see, Proxima Centauri b orbits around an active star. We call it active because it sends intense emissions and charged particles during events we call flares. And flares can be detrimental to life. But guess what? We also orbit around an active star, our very own sun. The sun might seem a little bit boring when seen in visible light, which is the light that we as humans can see with our own eyes. But look at it in extreme ultraviolet. It is a completely different beast. When solar flares occur, they send intense radiations that are responsible for radio blackouts here on Earth. Some of those flares are also responsible for what we call sunstorms. There are big clouds of charged particles traveling in space from the sun to the other planets of the solar system. If Earth is on the way of a sunstorm, this happens. Northern and southern lights. Beautiful natural phenomena. Beautiful, but also responsible for disrupting our telecommunication systems, disrupting our GPS, disrupting our electricity grids, and forcing us to reroute civil aviation planes. So imagine us right now without working mobile phones, no Twitter, no WhatsApp, no news wires. How will we find our way on the London Overground without working Google Maps? You tell me. So my job is to understand how solar flares occur and how solar storms propagate in space. It's like looking how volcanoes or tsunamis or earthquakes happen here on Earth, but in an even more challenging way. It is very challenging because we cannot send probes into the atmosphere of the sun where the temperatures rise to 10 million degrees. What we can do, however, is take pictures of the sun, like here, and try to use computer simulations to reproduce the different structures that we see during flares. With more powerful telescopes and more powerful computer simulations, my team and I are now able to reproduce the whole sequence from the formation to the ejection of the solar storms. Actually, recently, with the powerful simulations that we have been able to predict some of the sun's behavior that have been later on confirmed by telescopes. But more important to us, we want to know when those sunstorms arrive at Earth. A bit like Hurricane Matthew making its way from Haiti to Florida and North America. We want to know when the space hurricanes are going to impact the Earth. How do we do that? Well, we have sent probes in space, probes that are constantly monitoring the space environments of the Earth. But we are also a spacefaring civilization. And now, thirst of curiosity have led us to send probes to explore other planets of the solar system and other objects. Voyager, the Rosetta mission to a comet, New Horizons to Pluto, Venus Express, Messenger to Mercury. All of these are examples of probes that we have sent. And they are acting like tiny weather stations, space weather stations. They are collecting bits of information on the space hurricanes, a bit like weather station that we would have in Florida or Haiti or North Carolina that would have collected bits of information on Hurricane Matthew. And right now, by collating all these bits of information, we are working on generating the most generic shape of space hurricanes, as well as model the propagation from the sun to the Earth, Mars, or Jupiter. We are working hand in hand with national organizations such as NOAA in the US or the Met Office in the UK, so that our research results can lead them to have better space weather forecasting. Better space weather forecasting means giving the heads up to governments as well as industries managing satellites either for national security, telecommunications, as well as banking systems, and electricity grids. Because know that at the moment, our international satellite launch capacity cannot respond to the threat that we have in case of very severe space weather. What we can do, however, at the moment, is change the orbits of certain satellites or temporarily turn off certain vulnerable components either on spacecraft or electricity grids. So, in a few years' time, you might wake up in the morning, check the weather forecast on your phone, as well as the space weather forecast while brewing your morning coffee. Cloudy with a chance of sunstorms. We are actually very lucky here on Earth, because the Earth has a natural shield that we call the magnetosphere. Other planets of the solar system haven't been that lucky, and Mars actually has seen its atmosphere being depleted because of the intense winds and storms of the sun. But we are a spacefaring civilization. we have seen earlier our desire to go to the moon. If we're serious to go to the moon and to go to Mars, we need to better understand how the space weather works. And if humanity lives long enough so that we develop interstellar travel, we want to target an exoplanet that is in the habitable zone, but also has a magnetic shield like the Earth does. So how cool would it be if Proxima Centauri b did have a magnetic shield? But before we go to Mars, before we develop interstellar travel, I want to take you and your family and your friends on a space journey. I don't have a rocket though. And unfortunately, Elon Musk and Richard Branson are not my friends, at least not yet. What I have, however, is a virtual reality headset. With filmmaker Tom Saville from Treehouse Digital, we have developed an experience of what it would be like to be in space. And our first journey, you guessed it, is to travel through a solar storm. So welcome on our spaceship. What we have done is we have worked with local communities, schools, as well as science festivals to bring more than 1,000 people since the beginning of our project 6 months ago, and bring them from the Earth to the sun to witness the beginning of a sunstorm. Virtual reality, we have seen earlier, is a way to connect with people, is a way to increase the curiosity of people. What I have seen, though, is that virtual reality has given me a very powerful tool to show to people that the real reality is still full of wonders and beauty. I feel myself very lucky because as a child, I was able to look at the night sky. But with light pollution and city life becoming more predominant, this sounds a little bit like luxury. So we hope that this VR journey, and we're developing hopefully more of that, is going to give an incentive for our young VR astronauts to fight against their teachers and pursue their desire to find alien life. In a few years' time, this journey through solar storm is actually going to become even more real. In 2018, NASA and the European Space Agency are going to send 2 probes, Solar Probe Plus, that you see here, and Solar Orbiter. For the first time in humanity, we'll be the closest we've ever been. And for the first time, we will actually travel through sunstorms just born in the sun's atmosphere. Working every day as an astrophysicist is a constant reminder, is a daily reminder of how little we are in this big universe. And I feel very lucky to have shared what we know with you today. Thank you very much.